So, hello everyone again. This is lecture 2 part 2 of ray optics and optical instruments. In this we will start with a new discussion that is called as refraction. So, in refraction basically you will understand again what are the refraction laws, what is Snell's law of refraction, what is total internal reflection, what is the difference between a lens and a mirror, how are the refraction laws being computed and so on. So, let us start the discussion directly. I am Sameer Lavankar. Let us begin our discussion. Okay. So, first of all a course outline. So, basically right now we have completed with the introduction portion in which we understood the basic concept of light, that is it is a particle theory, that is ray optics, and we are understanding that light has a very large speed which is equal to 3 into 10 to the power 8 meter per second, and light travels in a straight line. In the reflection of light by spherical mirrors we understood the concept of mirror and also the basic definition of what is a pole, what is a focus, what is a principal axis, how are the rays of light being incidence, what is the angle of what are the laws of reflection and so on. In the last lecture we concluded the second point with the two examples. Today we will start with the third point, that is the refraction concept. So, what is refraction concept? Let us look over here. So, refraction. So, please look over here carefully. You may have understood this basic concept of refraction in your previous classes only. I will just iterate it again. So, when a beam of light encounters another transparent medium, a part of light gets reflected back into the first medium while the rest enters the other. So, as we know that each of the medium is not even 100% transparent, 100% reflective, any surface is not 100% reflective and 100% refractive. A part of it always gets reflected and a part of it always gets refracted. So, this is nothing but called as refraction. This is something which is happening of bending of light when passing from one medium to another is called as refraction. Okay. So, when a beam of light encounters another transparent medium, a part of light gets reflected back into the first medium while the rest enters the other. Fine. Okay. Next is a ray of light represents a beam. A ray of light represents a beam. So, a large beam basically rays a single line, and if we conclude it with a many rays of light like this, then it is called as a beam of light. Okay. Fine. So, a ray of light represents a beam. Now, the direction of propagation of an obliquely incidence, what does it mean by obliquely incident? That means the angle of incidence is between 0 to 90 degrees. Fine. Ray of light that enters the other medium changes at the interface of the two media. This phenomena is called a refraction of light. So, what does it try to say is it just tries to say, let us suppose this is the interface of the two media, let us suppose this is the angle of incidence of light based on normal, then as the light passes from one medium to another medium, it bends either away from the normal or towards the normal. So, either it can be towards the normal or away from the normal. This is its original criteria, but it does not follow this portion here. So, this phenomenon is nothing but called as refraction of light. So, basically the bending of light on attaining or on passing through a different media either towards the normal or away from the normal is called as refraction of light. Basically, it is a phenomena which occurs in normal surroundings. Okay, fine. So, this thing has been explained. Next is Snell experimentally obtained the following laws of refraction. So, basically again there are two laws of refraction again. So, let us look over to these laws of refraction. So, first is that the incident ray, refracted ray and the normal to the interface at the point of incidence all lie in the same plane. It is same as that of reflection, only reflection has been changed into refraction here. Okay. So, this is the only plane which has been talked about here. So, this is the plane in which the incident ray is also present, normal ray is also present, and reflected ray is also present, and similarly the refracted ray is also present in the same plane. Fine. Okay. Let us move on. So, this is the first law of this was the first law of refraction. Let us move on to the next law. So, the ratio of the sine of the angle of incidence, the sine of angle of refraction is constant. Remember that the angles of incidence I and refraction R are the angles that the incident and its refracted ray makes with the normal. So, basically what we have is for laws of reflection we had angle I is equal to angle R, where angle I is angle of incidence, angle R is angle of reflection. But for this Snell's law of refraction, the other second law states that the ratio of the sine of angle of incidence, the sine of refraction is constant. What is that constant we will get to know, but for now what we know is that the sin I by sin R is equal to n to 1. Now, this n to 1 is a constant which is called as refractive index of the second medium with respect to the first medium. Okay. This equation is well known as Snell's law of refraction. So, this is the same concept which you will also understand, which you will also learn in wave optics concept. I will try to derive the same thing there also, but for now what you need to remember, what you need to understand, that sin I by sin r is equal to n to 1. N to 1 is a constant which is called as the refractive index of the medium second, medium 2 with respect to the first medium. Okay, fine. Let us move on then. So, next is we know that N21 is a characteristic of the pair of media and also depends on the wavelength of light, but is independent of the angle of incidence. This line will be much more clearer when you will go through the wave optics concept, because everything related to refractive index has been explained there only. Next is from above equation, if N21 is greater than 1, R is less than I, quite evident, as you can see that as sin I by sin R is equal to n to 1, as you can see sin I by sin R is equal to n to 1, and it is given that it is greater than 1. What does it mean? It means that sin I is greater than sin R, as we are only and only incidenting the light at an angle which is obliquely incident, that is I is lying between 0 to 90 degrees. That means it is quite evident that I is always greater than R, quite evident. So, therefore, from such equation what we can see that if N2 is greater than 1, R is less than I, that is the refracted ray bends towards the normal. What does it try to say is, let us suppose this is the sequence here, let us suppose N21 is greater than 1. That means if this is the angle of incidence, if this is the angle of incidence, so this is the direction, let us say this is the angle of incidence, then always the refractive angle will always be less than. What does it mean? It just simply means that it bends towards the normal. So, this is the angle of refraction here. So, this is the sequence, or this is the explanation which has been explained in this line here. So, let us move on to the next line now. Next line says that in such a case medium 2 is said to be optically denser or denser in medium 1. That means it is denser and this is rarer, quite evident. Let us move on. So, this thing has also been explained. Next is, on the other hand, if N21 is less than 1. So, we just need to change the sequence here, therefore, we will get sin I by sin R is equal to N21, which is less than 1. Therefore, we will get sin I will be less than sin R, therefore, we will get I is less than R. Hence, this time what is happening is that the refracted ray bends away from the normal. So, just trying to explain that portion also here. So, what is happening in this sequence? Let us suppose this is the angle of incidence again, but this time the bending will be away from the normal. That means, this will be the direction of bending. So, this is the angle of incidence for you, this will be the angle of refraction for you. So, this time what does it say? So, on the other hand, if N21 is less than 1, the refracted ray bends away from the normal. This is the case when the incident ray in a denser medium refracts into a rarer medium. That means, this is denser medium now and this is rarer medium now. So, this is the only explanation which is being explained in these 4 points. So, this is the case when the incident ray is in a denser medium refracts into a rarer medium, quite evident. Okay, so, I explained you every line here. Let us go to the note now. So, what is optical density? Optical density should not be confused with the mass density, which is mass per unit volume. It is possible that mass density of an optically denser medium may be less than that of an optically rarer medium. Optical density, what is optical density? Optical density is the ratio of the speed of light in two media. For example, turpentine and water. So, mass density of turpentine is less than that of water. So, we cannot relate that if mass density is less, then that means the optical density will also be less. If mass density of turpentine is less than that of water, but its optical density is higher. So, we cannot relate mass density to optical density, only a simple theoretical explanation is being given here. Okay, fine. For your basic reasoning, you just need to remember what is mass density. Mass density is mass per unit volume, and what is your optical density? Optical density is ratio of speed of light of two media. In two media. Okay, let us move on. So, next point says that if N21 is the refractive index of medium 2 with respect to medium 1 and N12 is the refractive index of medium 1 with respect to medium 2, then it should be clear that n12 is equal to 1 by n21, very quite evident, because refractive index won't change. Only let us suppose for one scenario I will try to explain you one thing. Let us suppose this is the medium, this is the angle, this is the angle. So, what I am saying is that the angle is like this, angle is like this. Now, if we go with this angle of incidence, this angle of reflection, what I can say is that sin I by sin r is constant. What is its value? Its value is n21, where this is 1, this is 2. Now, let us change these values. Let us suppose I am angling. For the first case scenario, what I was doing is, this was my direction of propagation of light. In the second sequence, what I am saying is, let us say this is not the propagation direction, let us suppose this is the propagation of light. That means what is happening is, this is angle I, this is angle r. Again what I will try to say is, again sin I by sin r is equal to n12, but this time what is happening is, this I dash and r dash. So, this I dash is nothing but r and this r dash is nothing but I. Therefore, what we will get is, we can just equate both these equations to get that sin I by sin r is equal to sin r dash upon sin I dash from this sequence. So, let us suppose this to be equation number 1, this to be equation number 2, you will get this is equal to 1 by n12, and what is sin I by sin r? Sin is equal to n21, hence you will get this equation that n12 is equal to 1 by n21 or n21 is equal to 1 by n12. Okay. So, this thing also has also been explained clearly. Let us move on. So, this thing has been explained. Next is, it also follows that if n32 is the refractive index of medium 3 with respect to medium 2, then n32 is equal to n31 into n12. So, basically you are using the 3 mediums now. So, if you go on refracting, and then you will try to give the propagation first in this direction and the next time in this direction, then finally you can get this formula also. So, basically n32 is equal to n31 into n12, but what is n31? n31 is the refractive index of medium 3 with respect to medium 1. So, basically the calculations of n2, 23 and 32 gets cancelled. Okay. Let us move on. So, some value or it gets value 1. Okay. Let us move on. Next point is, so now we will understand a new concept called as lateral shift. What is this lateral shift and what is this apparent depth? So, some elementary results based on the laws of refraction follow immediately. First of all, let us look over to this rectangular slab here. So, let us look over to the rectangular slab, what is happening here. So, for the rectangular slab, refraction takes place at two interfaces. As you can see, first refraction is taking place at this location and second refraction is taking place in this location here, fine. So, first is air glass, this is air, this is glass, and next is again this is glass, this is air. So, it is easily seen from the figure that R2 is equal to I1. So, what is R2? R2 is this, I1 is this, as you can see quite evidently, because the ray of light is same only. Therefore, in the same medium it will go on the same inclination after passing through that media. Therefore, you can see that R2 is equal to I1. That is, the emergent ray is parallel to the incident ray, that there is no deviation, but it does suffer lateral displacement. So, why it suffers lateral displacement? Because of refraction of light. So, as you can see, it first bends and then it again bends. First it bends towards the normal, second time it bends away from the normal. So, that deviation, let us suppose it deviates by, let us say deviates by, let us say 2 degrees, then the next after going above it again deviates by 2 degrees again. So, that minus 2 plus 2 gives you the value again 0. Okay, so, it is easily seen from the figure that R2 is equal to I1, that is the emergent ray is parallel to the incident ray. There is no deviation, but it does suffer lateral displacement or shift. So, this lateral displacement is also called as shift with respect to the incident ray. Okay, fine. Let us move to the other example or other scenario in which refraction is possible. So, another familiar observation is that the bottom of a tank filled with water appears to be raised. How it appears to be raised? As you can see here only directly. So, for viewing near the normal direction, it can be shown that the apparent depth h1. So, this is the apparent depth. What does it mean by apparent depth? Apparent depth is that depth which our eyes can see. That means, let us suppose the value of a complete depth of water is, let us say 5 meters or let us say 2 meters, but the apparent depth will be, let us say 1 meters or let us say 0.7 meters. Why it will be less? Because of refraction of light, it appears to be a little above. The bottom of the tank appears to be little above than its actual height. Okay. So, apparent depth is real depth divided by the refractive index of the medium. So, as the refractive index keeps on increasing, the value of the height of apparent depth keeps on decreasing, or will sorry, the value of the height which we can view keeps on decreasing. Okay. So, just explaining it again. So, what is happening here again, as you can see that if you view the observer, if the observer is viewing like this directly, so you can see that the direction of propagation is happening in this sequence, and you can observe the image at this portion here. When you will try to view it from the some angle, that is lateral direction, what is happening again, that there is an image which is formed, and then you can see that the value or the image being formed is at the apparent depth h. So, basically what should have happened, that your eyes should view the location at the bottom point, but because of refraction it bends, and because of this bending you can observe the value at some apparent depth, which is this h dash. So, this is just happening because of refraction of light. I guess you would have observed this phenomena, you would have understood this phenomena in your class 10th also. So, let us move on. So, this is just a basic theoretical portion, that refraction of light also leads to lateral shift and apparent depth concept also. So, you just for this concept you just need to remember that h1 is equal to nothing but small h2 small h2 upon refractive index of water. So, n21, just writing it appropriately. So, h1 is equal to nothing but h2 upon n21. So, let us move on to the next concept now. So, now a new concept, you may have heard also this, that is total internal reflection. So, as the name suggests, total reflection is happening and internally it is happening, that means there is no passage from medium 1 to medium 2. Okay. So, this is the complete concept total internal reflection. I will try to explain it very slowly. So, what is happening when the light travels from an optically denser medium? So, let us suppose this is the denser medium, maybe we can take it as water, and let us suppose this is the rarer medium here. So, when the light travels from an optically denser medium to a rarer medium, at the interface it is partly reflected into the same medium and partly refracted into the second medium. So, what is happening is, as you can see that what is happening, some sort of is done as reflection and some sort of this is done as refraction here. Okay. Next is this reflection is called as internal reflection. So, this part which is happening is called as internal reflection. So, as the name suggests that there is something total internal reflection. So, as you go on increasing this angle, you will get a point at which the value of refraction will be equal to 90 degrees. After increasing the angle, apart from that angle which is called as IC, you will get total internal reflection. I am just briefing for now, because I need to conclude this lecture for now. I will try to explain this in detail in the next lecture. For now I am just trying to explain again. So, what is happening, as at some angle of inclination there is part reflection happening, part refraction happening, part refraction happening. Then as you go on increasing the angle, again reflection happened, refraction happened. Then at one point what you will obtain is that there is the angle of refraction is equal to 90 degrees, as you can see. That angle is called as critical angle, this IC is called as critical angle of incidence. Now, if you will try to move at a portion such that I is greater than IC, then you will get total internal reflection, that is the total ray of light is being incident in the same medium only. Okay. So, this is the complete concept of total internal reflection. Let me stop it here only. I will move on with the further discussion in the next topic. So, let me stop it here. Thank you so much.